So now let's look at the log equation. So here we have this equation, 4 plus log to the base 2 of 9k is equal to 2. So the first thing we want to do is get at most 1 log on each side, which means we need to move this 4 to the other side of the equation. So we have log to the base 2 of 9k is equal to negative 2. Now, the way you get rid of a log is if there was 1 on each side, we could cross them both out. If there's only 1 log, the only way to get rid of it is to rewrite the equation using exponents. So here's our base. 2 to the negative 2 power is equal to 9k. Or in other words, 1/4 is equal to 9k. To solve that equation, you divide both sides by 9, or in other words, multiply by 1/9. And so we find out that k is equal to 1/36. Let's try another like that. So here's a log equation. We need to get the log by itself, so we have to get rid of this 6 and we have to get rid of this 2. So we'll start by subtracting 6 from each side, leaving us with this expression. And then we'll divide both sides by 2. So now the log is by itself. Log of 8n plus 4 is equal to 2. And again, if you just have 1 log, the only way to get rid of it is to rewrite using exponents. You might say, well, what's the base? Remember, if the base isn't written, we assume it's a common log, or in other words, base 10. So we have 10 to the 2nd power is equal to 8n plus 4. Or in other words, 100 is equal to 8n plus 4. And now this is an easy equation that we can solve. So 96 is equal to 8n, so we'll divide both sides by 8, and we have a solution of n is equal to 96 over 8, and 96 over 8 is equal to 12. Another log equation. So on this side of the equation, we have 2 logs. And remember, our first step is to get at most 1 log on each side. So we need to combine these. How can we combine them? Well, remembering our laws of logs, subtracting the logs is the same as dividing. So we have log to the base 8 of x plus 6 over x is equal to log to the base 8 of 58. Now look at how this equation is different from all the others. In the other 2 that we did together, when you looked at the logs, there was only 1 log on each side of the equation. The only way to get rid of it was to rewrite the equation using exponents. But here we see we have a log on each side. We can cross out those logs. Remember, if you do the same thing to both sides of the equation, you still have the same solutions. And so we have x plus 6 over x is equal to 58. We'll multiply both sides by x. X plus 6 is equal to 58x. 6 is equal to 57x. Dividing 6 over 57 is equal to x. And notice that just a quick check shows that that would be in the domain of this function, and so that's our solution. And finally, we have an application problem. In 2010, the population of a certain city was 72,000, and the population was growing exponentially at a rate of 0.1% per year. So as a decimal, that would be 0.001. Well, when did the population of the city reach 80,000? So our formula for exponential growth is our final amount, whatever you want to call it, is equal to our initial amount times our rate to the t power. All right, so our final amount, this is our final amount, this is our initial amount, this is our growth rate, and this is our time. So our final amount, and we can, why don't we just say we're working in 100,000s, because that way we don't have to keep all of the zeros around. So our units are going to be 100,000s. Okay, so I'm going to write 80, 100, or sorry, it's not 100,000s, it's 10,000s. Or just thousands, I should say. So 80 is equal to 72. So 80,000 is equal to 72,000. Our growth rate is 100% and an additional 0.001 each year to the t. And so we'd like to solve this equation. We'll start by dividing both sides by 72 to get the base by itself. So we have 80 over 72 is equal to 1.001 to the t. That's an exponential equation, so we'll take the log of each side. Taking the log of each side allows us to bring the power down. So we have the natural log of 80 over 72 is equal to t times the natural log of 1.001. To get t by itself, we simply have to take both sides of this equation and divide it by the natural log of 1.001. That will get rid of it on the right side, and if we put this into our calculator, we'll have our answer. So the natural log of 80 divided by 72, and we want to divide that by the natural log of 1.001. And so that comes out to be t is equal to 105.4. So it's going to take a long time before the population of the city reaches 80,000. If time started in this problem in 2010, it would be 105 years after 2010. So 2010 plus 105 years, that would be the year 2115. And those are the solutions to this week's problem set.